Thanks, Adam. Greetings, everyone. We've got an interesting discussion today with two gentlemen, one from Houston and one here outside London. So we've got the globe covered again. Cetin Karakus is the global head of Quantitative and Analytical Solutions at BP, joining us from Houston. And Adrian Fielding, General Manager, Safety Initiatives for Plant, Global Integrated Protective Solutions, Honeywell Process Systems, here just outside London also. So welcome, gentlemen. Like to get each of you to say hello and give a little background on yourselves. Cetin?
Hello, everyone. Cetin Karakus. I run the Quantitative and Analytical Solutions at BP. I'm a software engineer by training. My background is in financial engineering and data analytics. But we are a major energy player both in financial and physical space. And I have got involved in the kind of the physical aspects of the energy complex, energy trading. And I hope to bring that perspective and data analytics perspective to today's discussion.
Thank you. Adrian.
Hi, thanks, David. So I'm Adrian Fielding. I'm based in the UK. I'm the General Manager for Safety Initiatives within Honeywell Process Solutions. It's a global role that addresses our hardware and software solutions from plant, personnel, asset, and general safety, including environmental health and safety. And I'm really going to come from that angle on how digitization of safety and the digital twin associated with that is really going to enhance safety performance and productivity in the future.
Oh, that's good, Adrian. Thank you. So the first topic we had was how to maximize the current infrastructure model, incorporating digital asset visualization. So there's the whole spectrum of creating a digital twin, using that information, whether it's in some project phase, to provide information to the users to help them visualize the asset and then perform these. So Cetin, I wonder what you could share with us on that topic.
Yeah, I think there are several aspects to if you go down that route. I think, first of all, you have to start with a comprehensive instrumentation and data collection. So that involves in your physical infrastructure landscape, having, for example, extensive sensor network, collecting data from IoT devices. In industrial setting, that will be like a SCADA devices and kind of machinery infrastructure. Once you kind of collect that extensive data, that will allow you to map out your physical infrastructure, know what you have, where it is, and essentially kind of keep the heartbeat of the physical infrastructure that allow you, do real-time monitoring and control. And also important in this regard is when you roll out new infrastructure and when you put into new devices, or if you're building like custom devices, you have to ensure that you keep that instrumentability as a kind of one of the key design issues. I mean, we've seen sometimes like third-party devices which doesn't really have enough instrumentation capability, which sometimes force you to come up with your own kind of custom device, because that kind of the data you have to collect from those devices when they operate is really critical to be able to manage that. Now, once you have that as a kind of a comprehensive data collection and instrumentation infrastructure in place, then obviously you can move into the kind of a more advanced stages, which we will talk more details in later discussions. One is always a digital twin. So essentially, this is based on building kind of a digital representations of those physical devices and infrastructure based on the data analytical models. So it is it relies heavily on the comprehensive data collection and kind of building model of the physical entities out of those data. So it's obviously very much data intensive and data driven. You could obviously use some of the kind of the more automated ways to build such models, but then as in machine learning, you can refine those models, incorporate the kind of expert insights, and there are kind of different ways of doing that. Related to these digital twins is what's called the hybrid twins, which are more like using kind of a simulation, physics-based simulation models. So the difference we will probably discuss later in more detail is more around using more kind of expert insights or kind of a theory-based model instead of just relying on the data collection and the kind of data analytics-based methods. And once you have this kind of comprehensive networks and digital or hybrid twins, then I think the final and maybe most important stage is putting all this into kind of a mission control center, where it's essentially you create some sort of a nerve center where you constantly collect your data. You have a place to kind of control it. Obviously, you have to visualize it and make it in a kind of such a form that the operations people can really understand what's happening in the physical space. And this will enable you to well, you have to make it like an operations grade. So it has to be really kind of in terms of the latency of the data, in terms of how it's kind of represented, so that the operations staff can really relate and understand, and kind of monitor what's happening in the physical space. And this will allow you to constantly improve your physical infrastructure. So if you see that there are some shortfalls in terms of the way you're collecting data, if it kind of prevents you to control or react to the changes in a timely way, then you could go back to the previous stages and then improve your either data collection capabilities, or improve your data analytical modeling, or kind of physics-based modeling approaches. But mission critical system is essentially very important. How that is the whole thing kind of come into life.
Yeah, that's good, Cetin. We've got the data, we've got the digital twin, we've got the control hub. Now we had these users, that some of the people with devices and everything. How hard has it been to have the communication links, to get that connected into these users, whether they're walking around with a smart device or an iPad or something in the field? Has that been able to be managed, that challenge?
I mean, yeah, it is depends on the very much. I think the way you kind of visualize things in the mission control system will be probably very different from the way you will do that in kind of fields with the kind of handheld devices or some of the kind of wearable devices for the operation stuff. Because obviously in the latter, the kind of priority is a bit more like task specific. And you don't have really that much computing capabilities. Some of those devices, have really kind of a limited screen estate and computing power. So there it's more like essentially task, command specific, instruction specific analytics or visualization. Maybe like you can't tell the person whether something needs to be done and what it is, not like seeing exactly what's happening in the entire infrastructure. So I think that kind of brings me to kind of that topic, the thing about making things like specific and useful for the operation stuff. So the people in the control center, they will they will require kind of a more global kind of perspective, what's happening around in many places, whereas people in the fields, for them will be like essentially a list of kind of tasks and what they need to do. And also I think another important thing is for the field staff is having some sort of a link between the devices they are using and then what they are seeing on the on the field. So having something like something RFID or some sort of a identifier on the physical device, which can quickly link with their handheld devices to identify what they are looking into and kind of collect the data kind of piled up in that particular device will be very important. Yeah, I mean, it could be. This is the part I think it could really make things kind of make and break type of thing, because for the people on the fields, it's very important that whatever you come up with, it has to be really robust and kind of working, instead of like the priority is not about having more advanced or kind of more comprehensive solution. It's more like even if you have a basic things, it has to work and it has to be really reliable.
Good. Yeah, maybe that's something you could pick up, Adrian. We've got the user out in the field. If we're trying to get data to him, as Cetin mentioned, task specific, but we want him to not just do the right thing, but do it safely and make sure he has physical safety of what he's doing. What do you think about that?
Yeah, I mean, I think, well, let me take a step back a little bit first, Dave, because I think there are many different views of what constitutes a digital twin. I mean, the obvious one that springs to mind is the full-blown 3D graphical view of the plant that mirrors exactly what is going on outside the control room, and all of the operations associated with that. But I think what we have to ask ourselves when we're looking at current infrastructure and the data from the devices is, what is it that we really want from a digital twin today? What resources are needed to commit to make that happen? And is it more reliable? And more importantly, can it be maintained accurately? Whether it be a digital twin for a single device or whether it's a digital twin plant-wise, any change needs to be reflected on that digital twin consistently. Otherwise, what we're looking at is just some fancy graphics. So we need to understand the problem that we're trying to solve and what the benefits are. And so really, I think what happens, we don't go straight through to 3D graphics. We end up doing a piece at a time because we want to look at return on investment. Companies have invested multi-million pounds, dollars into their facilities and their operations, and a lot of that maybe you're not able to pull the data from. So you need to do it a piece at a time. So and it's only then you get that accuracy of data. As Cetin mentioned, you need the accuracy of data, and it needs to be there when you want it there. So when we then look at how we're putting a safety view on that, when we're looking at putting workers into the field, it really starts from when they get to site. At the moment, we're doing a lot of manual operations around qualifications, certifications. Has the guy got the right PPE? I think digitalization of that process, we're seeing more and more. I think the digitalization within the worker safety is accelerating rapidly, in particularly with COVID, when companies were losing a whole shift with one positive COVID test. You can ill afford to do that. So we're seeing remote operations that require the information and the data that we're talking about here. But more importantly, if you can streamline workers, make sure that they've got the right competency, the right compliance, so they're not fatigued, then you provide them potentially with virtual reality or augmented reality training. And once they've ticked those boxes, it allows them to have a permit to work. Now, automating that whole process, including the permit to work, now you're seeing data in real time. And I'll give a great example for safety and how this all interacts. If I'm working on a permit on a hot permit, and the unit next door to me gets a gas leak detected, then I want that permit suspended and I want to be evacuated from there as quickly as possible. And paper formats do not do that. So digitalization is going that direction, but you need the data, and the data absolutely has to be accurate and well maintained.
No, I like that. You know, when a worker goes out in the field, he's concentrating on the task he has to do, but on the other hand, the organization wants to make sure that all the necessary preparations have been done. So you mentioned the competency of the person, very important. Has the necessary HAZOP been done to allow that work to take place? Does he have the right kind of tools? Does he have the right spare parts or whatever that he needs to take with him? Has the necessary isolations been put into place? So the digital twin that's keeping a track of all the IoT data coming in, you know, the guy wants to work on this bit of kit, and is it properly isolated? Unfortunately, there's plenty of instances where there was a train of 4 pieces of equipment, and the wrong piece was isolated, and on this one FPSO, they went over to the unisolated one as part of a blowdown system, took the valve out, and only then discovered, wait a minute, this is still live. If there was then a subsequent emergency, the whole inventory of the FPSO is going to come through that removed valve location. So we have to provide real-time information to the workers to be safe. So knowing before they start, but while they're going on, I like what you mentioned about if there's a gas release or something happens nearby. It'd be great if a guy had a smart device that suddenly goes red and says, no, you got to stop working, and you know, here's some information you need to know that's impacting your work. You know, it's a great way, a live, active digital twin gathering lots of information can then feed it to the user, whether it's an operator or someone doing maintenance. The next topic we're talking about is extending the life cycle of an asset, accelerating digitalization. Obviously, sometimes we've got brownfield resources that we're wanting to use these technologies and tools in. You know, how we might want to get them more digitalized to be able to improve the working and also the safety there. Cetin, do you have experience with that kind of a subject?
Yeah, I mean, I have some views, not specifically, maybe not. I mean, I'm more, you know, involved in the data analytics space, but you know, some of that data come from the physical assets. So I'll provide my perspective on that. I think there are kind of 3 main points or areas how kind of you know, this digitalization could help with the extending the life cycle of these physical assets. So the first area is around the we'll call it the optimal adaptive maintenance scheduling, right? So obviously physical assets kind of, you know, depreciate, deteriorate, so they have to be maintained on a certain schedule. So this could be done obviously in a kind of a traditional way where you have this schedule of maintenance tables and you basically, you know, visit your physical infrastructure from time to time. It is an acceptable method, but with the digitalization and all the kind of the constant data collection associated with that process, we could do better. We could essentially keep a kind of a heartbeat of the physical assets, and you know, collect performance metrics, any faults happening on the devices, maintain kind of logs, what has been done and what such faults caused, and using all that data, then we can essentially kind of update our maintenance schedules, right? So, for example, if certain physical assets kind of, you know, approach their progress through their lifetime, they're likely to be, you know, failing more often. So you might kind of do more kind of a proactive maintenance, or you can increase the frequency of the maintenance schedules. So you could do a lot of kind of adaptive scheduling improvement or maintenance improvements on how you maintain your assets, and that could certainly optimize and lengthen the useful lifetime of those such physical assets. Second area will be around kind of Adrian mentioned and you mentioned before, is essentially enforcing some of the best practices, how the people operations staff deal with using and maintaining those physical assets. So you might, I mean, the standard way here is essentially having checklists and people kind of following certain procedures before they go and do any physical operations. So that heavily relies on obviously someone following those checklists and protocols. But when you have the digitalization, you could in fact incorporate such protocols inside the control and kind of control software in the devices used by the kind of the operation staff, and that way you can actually have better way of enforcing the following those protocols and best practices and avoiding costly mistakes. How such physical asset can be used or maintained, repaired, etc. And thirdly, I think the digitalization or digital twins kind of allows what I call the reduced interference with the actual physical infrastructure. So when you have a kind of a data analytics and digital twins, you could, for example, for training purposes or some of the kind of more experimentation, what if type of purposes, you could perform such kind of intrusive operations on the digital replicas first, see the effect before you could actually going and doing it in the physical infrastructure. I mean, we've seen a lot of cases where people kind of tried certain things, maybe with good intent and for good purposes, but that could cause some serious issues in some other part of the plants, for example. So that kind of reduced interference could also help with the extending the life cycle of the assets.
Yeah, that's a good point you mentioned about the sequence of actions. One use that I don't think has been mentioned enough about digital twins is the idea that as they progress through from engineering design phase through towards operations and everything, there is something called an operations training simulator, OTS, that's based on a digital twin, a process and controls digital twin, and it's a way of training operators. Because we've seen in the North Sea, there was a survey done a few years ago where on looking at a bunch of trips of gas compressors, and about 20% of the trips were due to operators not giving the optimal response to fairly normal variety of process conditions, and then people reacted in a certain way and it led to a trip. And so the idea that we can use a digital twin both to train people but also to then track various operators. Some operators are going to be good, other operators are going to need some more training because how they react, they're not always doing best practices. So it's a powerful tool, and if they're doing best practices and doing things in the right sequence, it's inevitably going to be more safe. So I like that. Adrian, extending the life of an asset, accelerating digitalization. What can you share with us on that?
Yeah, so let's maybe focus on digital twin of a particular asset, say a pump, for example. We don't want a pump to be operating in surge, or we don't want it to be cavitating, because both of those actions dramatically reduce the life of the device. So, and sometimes we'll say that pumps aren't protected against this, but even when they are, it's possible to miss those alarms. So, and let me just think during the commissioning phase, the amount of alarms that you've seen in the alarm log, and it's just one alarm entry, which is pump cavitating, but all the time it is, then you're dramatically reducing the life of the pump and ultimately ends in failure. So a digital twin there you're then analyzing the health of that pump at a particular time. You are monitoring its performance, and through analytics, you're now able to predict the life of that particular pump. But also by analyzing that data, you're able to do other things with it. So whether you're escalating the alarm through the system, which you can do now. But now you're saying, I'm not only just escalating an alarm, I'm saying that this pump needs maintenance now, and maybe automatically generate a maintenance action, with pretty much what Cetin's just said. Now, that is important, and moving forward, we're going to see a lot more around how that impacts safety. And I'll give an example. So if we've got a valve that releases some gas, the first thing we know about that is a wearable gas device and an alarm to the control room. So now we know the gas and we know the location, and we can compare that with the fixed devices. So now we've got 2 data points for that particular release. Now, once we bring into the and some AI and machine learning and data analytics around, okay, well, those are the 2 safety devices that I got information from. So what about the process devices? So now I find that that particular valve, there was a lack of maintenance on that particular valve. So now I can go back, and maybe it was 3 occurrences that made that fail over time. So with the artificial intelligence and the machine learning, you're now able to look at that and go, I've got all of this data, need the data, and now I can say, well, when I had a gas release there, these are the 4 things that happened that preceded that gas release. So now if I go and send a maintenance guy out after I see 2 or 3 of these, then I prevent a future gas release. And that's the direction we're going. And that's really where the value is of digital twin from a safety perspective. Now, Cetin talked a lot about maintenance. And yes, if you're seeing pumps or whatever the device is, and it's got an issue and it's reducing the lifetime, then all of a sudden your maintenance goes up. But conversely, let's think about if we can monitor when we've had a shutdown of a particular part of the plant, and maybe the valve has closed and reopened, and the stroke time is all good. Then now we're looking at, well, that's moved. So the stroke time was within limits. So now we can take credit for that, because that's what we would have done in the maintenance of that valve. So now I don't need to go back and maintain that valve. So it's a fine balance between maintaining everything on time, but also taking credit for when the devices worked correctly, taking maintenance credit for that, because we're all seeing a reduction in workforce in the last 18 months, even more so. And it's important that we're taking the data and we're able to analyze that, but work more efficiently and more safely as a result.
Yeah, that's great. Yeah, we've heard over the course of the conference about hybrid digital twins. So we have physics-based digital twins, we have machine learning-based digital twins, we have digital twins that's getting real-time data. How do we sort of integrate that to get the value, Cetin?
Yeah, I mean, digital twins are mostly, relies on the kind of extensively collected data. They are built out of using data analytics models to kind of replicate the reality of the physical assets. The way you do it is, like, obviously you rely heavily on the data you collect from sensors. So, for example, if you have a wind turbine, you might have several, almost dozens of strain sensors on a blade. You might have some sensors on the gearbox to measure the temperature. Some other about the kind of the vibrations, etc. So you collect all those data 24/7. And kind of build kind of a model of the device, physical assets, using increasingly more kind of sophisticated data analytical models, like machine learning models. The issue is, obviously, this is a very data intensive process. So your sensors might fail. So whenever this data links between the the actual physical device and your digital replica fails, then that will affect how the sort of signals or the virtual reality you're creating out of that data to kind of degrade, right? So if certain sensors are not sending you correct data or not sending any data at all, then the physical representation you're going to come out of from the totality of the data you have will obviously be suboptimal. So that's the kind of one of the biggest issues with the digital twin approach. And hybrid twins is a bit more kind of using a more kind of a physical based models where you have an underlying theory and representations of how the physical device operates. So then you can easily establish like a cause and effect type of relationships. You have some sort of a kind of a model, like a handcrafted model, as opposed to some sort of model or system inferred from the data collected. So it's a lot more robust against kind of data failures you might encounter with the digital twin approach. And also it has another biggest advantage, which is because it's a kind of a physics-based model. There's an underlying theory, and therefore there's an understandability of how it actually operates. So some of the sophisticated models we see in the machine learning space, for example, deep neural network, etc. They kind of they might give good results in terms of the how the effect of certain parameters is going to be reflect in terms of the outputs you're going to observe, but how that operates or how that works usually is a bit like not that clear. So it's a bit like a black box. Whereas with a kind of hybrid approach, you have a physical theory about those causal dynamics of how the device operates. So you're kind of less likely to be affected by the sensor failures and then kind of a missing data you're kind of collecting from the devices.
Okay, great. Adrian, hybrid digital twins, how does that factor into this picture?
Wow, it's complex, right? And I think to Cetin's point there, single sensor failure and the models fall over. So sometimes I think you've got to take a step back and look at, well, do I need a digital twin here? Or maybe there are alternatives around simulation that'll do the job just as good. And so I'll give an example of that maybe. So let's say we've got a full 3D digital twin with a hybrid solution, so everything's working great, and it's on a mobile device with a worker in the field, and he's going to service a pump. So he can see on the mobile device the location where he needs to be, and then there's 3 pumps in that vicinity, let's say. So and he needs to know which one to work on. Now, what he's relying on here is stability of communications, good battery on the device, visibility of the device, depending on size, and accurate information. And he's relying on that digital twin for all of that information. But and like I mentioned before, that digital twin doesn't tell us if the worker is fatigued, if he'd been exposed to excess noise, excess heat, or cold. So we're assuming for now that the worker's in good health with the right PPE. But if that digital twin is then failing, does he go ahead with the job? Not sure which pump there is that he needs to be working on. So if you look at an alternative, he could have done some virtual reality training, like you mentioned earlier, David, before going into the field. And with that headset, he's able to see the 3 pumps. He knows he's working on the center one. He can go out. It doesn't matter if the device fails over that time, because he's in the field and he's seen what it looks like before he got there. Secondly, over all of that, what's to prevent us using, and to Cetin's point earlier, RFID or near field communication, possibly even Bluetooth, where the worker's tag or gas detection device is communicating with the tag on the pump. So he knows that he's at the right place and he knows that he's working on the right pump. The result's the same. You get an operator working in the field on the correct pump. You're doing it safely and with a compliant worker. But everything relies on the data, and if you can't guarantee the data is going to be at the fingertips of the operator, then you need to be taking advanced precautions in the training, in the visibility of the particular task, in advance of the worker going out into the field. And I think whether it's full digital twin, hybrid digital twin, the accuracy of the data and the modeling of the data needs to be accurate, and it needs to be maintainable.
Yeah, good. Yeah, one of the questions from the audience: have you considered using digital twin as a pathway towards remote operations, which will improve safety? And it reminds me of the idea that we always talk about. The number one safety risk is taking a person to and from a remote location, and the second greatest safety risk is him being there in a hazardous zone. So the challenge to do remote operations, remote monitoring, remote diagnostics, remote operations is quite compelling. And I guess people have had to do some of that over the past year with COVID. We've had reduced ability of people to physically go places. So, you know, digital twin especially a hybrid digital twin, provides us with a great opportunity to have both the physics-based model, maybe the theoretical model telling us what sensors ought to be, the data that's coming in and telling us what the data is actually coming in from those sensors, and do we have an issue or not. So the ability to do a virtual inspection was pretty interesting to me. Even the idea of putting on a virtual reality headset and walking through a 3D CAD simulation of the facility, but there on each piece of equipment, that as I walk by virtually, I can see the real-time data. I can see temperatures, color-coded. I can see if things are vibrating. I can get so much data. You know, that's quite attractive visualization of the future, is, you know, not putting people out there, but using either fixed devices or perhaps robots, perhaps drones, perhaps ROVs to go do the inspection with the remote operators in the central control room. You know, that's going to be a tremendous improvement in personal safety. Now we just have to make sure that we are actually knowing that the facility itself is safe, that these virtual remote inspections are actually capturing everything that a person there immediately adjacent to the equipment would have noticed. So we've got about 11 minutes to go. I wanted to give each of you an opportunity to kind of wrap up things. Cetin, how would you like to wrap up this general subject?
Yeah, I mean, we talk about the reliability and safety, and I think the digital twin technology definitely helps with this. So I'll just kind of talk about the several areas how, in summary, it does so.
Cetin's screen is, yeah, his screen froze there. Adrian, why don't you wrap up, and then we'll swing back to Cetin.
Yeah. Okay. So, so you just talked there about remote operations and ensuring safety and effectiveness of workers on site, and we've seen that a lot with Honeywell in the last 12, 18 months, where a significantly reduced workforce. So, what we've been implementing over that time is providing a headset with what might be a junior guy on site to go and perform maintenance tasks and feed the audio and the video back to the more experienced worker that over the last 12 months has been isolating at home, right? So, and what that enables them to do is to directly communicate. You've got the knowledge of the experienced worker right in the head, in the ears, and the eyes of the guy in the field, and he's able to look at documentation, verify the pump, and all of that information. So that's what we've been doing remotely. But I'd like to touch on an area where we are using digital twin for process safety in particular. Imagine you've got a complete safety lifecycle solution, software platform like Honeywell's Process Safety Suite, and it's able to compare in near real time your process safety risk with the design parameters of the system that were done during HAZOP, LOPA, SRS, and obviously the cause and effects. Now, if you've got several items in bypass, you're able to, they're likely to be pushing your dynamic risk matrix, so the risk matrix that we set right in the design process, you're likely pushing that into the amber from the green. So that's not really a great place to be. But what we can do with the digital twin there is we can say, right, if I've got a maintenance task and I have to put an IPL into bypass, how is that going to impact my system? So we do it on the digital twin, like a simulator really. And then we say, oh, that's going to take us into the red. And nobody wants to operate in the red. So I can then go back to the digital twin and say, right, so which loops do I need to take out of bypass to enable me to maintain this critical component without going into the red? And then once I've finished, I can then put those back in bypass and move along from there. And so that is something that we're working on now. So and is available now. And we think that brings a lot of value to the industry, where you're maintaining your level of process risk and you're getting visibility of that. But more importantly, you're able to simulate the impact of maintenance events on your system before you send the people out there to do it. And I think that, coupled with all of the data that we're seeing from safety and process devices and the machine learning and analytics that will be done on that. And like Cetin mentioned, that's really data heavy, but it's the direction we're going in. And certainly it's going to mean for a more efficient workforce, a safer workforce, and overall a more productive and profitable workforce.
Yeah, it'll be interesting to see how this continues to progress as technology, especially the communication tools, keep advancing. You know, we're getting thousands of satellites put into the sky, and even the idea of 5G to satellite is flying around. So the idea that every worker, Cetin's back, every worker could be connected at all times to get data that he needs for his task, but also helping make sure he's safe. If he stops moving or he has an issue, support can be directed to him. So there's a lot of ways that we can provide support to him. Cetin, a final wrap-up point for you.
Yeah, sorry, something happened with my camera. I was saying that the digital twin technology could be quite useful for kind of asset reliability and the safety. And the way it does it is, you could have a continuous data collection, getting all your data from the systems and sensors, and build up a bigger picture. You could also collect data around the faults and incidents, so you could see that how the physical infrastructure is degrading, and is it causing voltages and the frequency between those faults, and you could keep track of that to build some analytics out of that. And this will also help you, do real-time monitoring and kind of and reactive operations, so you can see what's happening, and if there comes some serious issues, you could react to that. And then all that data and kind of monitoring your physical infrastructure will obviously pave the way to build more kind of a dynamic data-driven models, and these models can then be used to do kind of optimal adaptive scheduling, being kind of a proactive, bit like moving in Inception. You could actually react to the bad devices or infrastructure assets before actually a serious fault happens, because you could see that there are kind of their metrics and that there are kind of changes in the KPIs, and you could have a kind of a more proactive approach. and all this I think will help with the lengthening the length, kind of increasing the useful lifetime of the assets, preventing the serious problems, and also helps with obviously training your staff, ensuring that certain, because it's all kind of based in software. Ultimately, you could encode the best practices and the certain protocols inside the system, so that it can be always guide the operation staff to what needs to be done. So that kind of helps with the preventing the major issues as well.
Yeah, no, it's good. It's a good optimistic view of the future. We've got technologies and tools here to help us through the whole life cycle of an asset to ensure the asset quality, the asset integrity, and really safety is personal safety, it's asset safety, it's community safety. Where sometimes these assets are located where if we had a release to the atmosphere or to the waterways, that can be a wider safety issue. So, digital twins, hybrid digital twins, keeping a watch on things, keep looking at the actual physical properties, what's happening. These are so powerful, and it's just becoming, it was only a few years ago where this was not talked about that much, and now every single conference, every single webinar, people are touching on this. So it's quite an optimistic view of the future, that the work that you guys are doing in your companies, all the technologies and tools, the practices, the culture that's building up, where people see the digital twin as an enabler, a facilitator, something that's going to help them be safer, help them do a better job, help them accept it better, helping executive management far away trust their people closer to the assets to make decisions from these insights without having to wait for some sort of time lag of hierarchical decision making. So it's a good future view. So thank you very much, Cetin, Adrian. Appreciate your time, and it was good to learn stuff from the two different perspectives. And I'd like to see if we could hand back over to Adam. Thanks, guys.